Is the screen visible, all of you? Okay, fine. So without much ado, let's start with the session now. So basically today I'm going to discuss with AR and VR, that is augmented reality and virtual reality. It's very interesting technology in today's scenario. You might be knowing now there are various important emerging trends like artificial intelligence is there, machine learning is there. Somewhat on the same basis, this is also one of the important technology, that is augmented reality and virtual reality. I will share the screen once again. Just give me a second. I hope everybody's screen is visible. Okay, fine. So thank you so much for your acknowledgement. So let's start with the session now. The topic which I am going to discuss today, that is augmented reality and virtual reality. So let's understand what is augmented reality. So basically it is a combination of a real scene viewed by a user. It is a virtual scene generated by a computer that augments the scene with additional information. So basically it's a combination, all right? It is very important technology. There are various important toolkits also available when I talk about AR and VR. AR toolkit demo movie toolkit is also available. Then T Immersion 2004 video, you can watch it so that you will get an idea regarding how exactly augmented reality works. At the end of the session, there are certain practicals for electronics and telecommunication. And those practicals I have developed using this particular technology, AR and VR. You all are already aware of resistances, resistance in series, resistance in parallel. And suppose if we want to measure the voltage and current and equivalent resistance, when the resistance are connected in series and resistance connected in parallel, what exactly value we get? So basically that practical I have developed using AR and VR. So I'm going to play that particular video at the end of the session so that exactly how you will come to know how exactly AR and VR works. Now let's understand what is the difference between AR and VR, augmented reality versus virtual reality. So when I talk about augmented reality, basically a system augments the real world scene. User maintains a scene of presence in real world. It needs also a mechanism to combine virtual and real worlds. And finally, it is hard to register real and virtual. On the other hand, when I talk about virtual reality, it is a totally immersive environment. Scenes are under control of system, need a mechanism to feed virtual world to user, and hard to make VR world interesting. So that is the difference between augmented reality and virtual reality. Now, Milgram's reality virtuality continuism is very important. There is one more important technology, that is mixed reality. So basically, when I talk about augmented reality and virtual reality, mixed reality, it is a hybrid scheme. It is a combination of both, that is AR as well as VR. So when I talk about mixed reality, basically you will require a real environment. For real environment, then we are going to develop AR, that is augmented reality, followed by virtual reality, and then finally we are going to talk about virtual environment. So Milgram coined the term augmented reality. Remember this. Milgram developed this particular concept, that is AR or augmented virtuality, to identify the systems which are most synthetic with some real world imaginary added, such as texture mapping video onto virtual objects. Combining the real and virtual worlds. So whenever we are talking about augmented reality and virtual reality, exactly what you will require from your side. So first of all, you will need a precise model. That is very important. Suppose if you are doing some of the practicals on breadboard, so breadboard is required, then resistors, capacitors, inductors, potentiometer, which is a variable resistor. So all these electronic components are required. So I'm giving example for electronics and telecommunication background. All right. If you want to perform some of the practicals in computer department, so again, suppose if you want to install Ubuntu or something, Linux operating system for Windows 7 or Windows 10, those practical also you can develop using AR and VR technology. So you will require a precise model, location and optical properties of the viewer or camera. Display is also required, very much important. Calibration of all devices, and to combine all local coordinate systems centered on the devices and the objects in the scene in global coordinate system. Combining the real and virtual worlds, which we are talking about right now. So you can see register models, 3D component model development is required. 3D objects of interest with their counterparts in the scene. Track the objects over time when the user moves and interacts with the scene. Realistic merging. So whenever you want to do realistic merging, it requires objects to behave in physically plausible manner when manipulated. Occultation, collision detection, and shadows. So these are the certain requirements whenever you want to do merging. To be more precise, realistic merging. Research activities. Develop methods to register the two distinct sets, real and virtual, of images and keep them registered in real time. This often reduces to finding the position of camera relative to some fiducial markets or markers. Develop new display technologies for merging the two images. Suppose if you have two images and if you want to merge them, those two images, that is also possible with the help of AR and VR technology, that is augmented reality and virtual reality. Performance issues. Two performance criteria are placed on the system: update rate for generating the augmenting image and accuracy of the registration of the real and virtual image. Also, you have to update the rate and can limit the registration accuracy as well as Brooks paper. So basically, when I talk about 1 millisecond, it is basically 1 millimeter error. So whenever you want to perform any practicals, all right, it is very much important. First of all, you will require a kit or the components which are required. Suppose you are performing the practicals as far as electronics and telecommunication background is concerned, then you will require a breadboard, then resistors, capacitors, inductors, potentiometer, then regulated power supply, So all these are required whenever I'm talking about electronics practicals. Suppose if you want to perform practicals based on a computer department, then you will require a computer system, laptop. Then you will require a keyboard. So that thing is also possible using AR and VR technology. Failures in registration. Failures in registration is due to noise, position and pose of camera with respect to real scene, image distortions, time delays in calculating the camera position. So there should not be a delay because everything has to be synchronized properly. So that also you have to take into consideration. Time delays are very much important so that everything goes smoothly, and synchronization is very important. All right. Now let's discuss about the display technologies. Now there are various display technologies are there. You have a monitor based. So when I talk about monitor based, you have a laptop, cell phones, projectors, more ubiquitous computing. And when I talk about head mounted displays, there is a video see-through and optical see-through. So these are the various important display technologies. Then you have a LCD also, that is liquid crystal display. That is also one of the important display technology. Monitor based augmented reality. So this is one of the example which you can see. It is simplest available. Treat laptop, PDA, cell phone as a window through which you can see AR world. Sunglass demo. So in this particular block diagram, you can see this is a real world. This is a camera position which is interfaced with video merging and a graphic system. And this is basically, this is my desktop computer, augmented view, optional and recording camera. So camera position is also adjusted in such a way that you can see how exactly in virtual world and real world exactly the entire setup looks like. Monitor based AR. So basically it is a successful commercialization. Yellow line in football broadcast, glowing hockey puck, replace Times Square billboards with own commercials during New Year's Eve broadcast, baseball cards, AD cap campaigns, etc. So this is just basically right now I'm giving you the introduction for AR and VR. Lastly, you will enjoy this particular session because exactly you will get the knowledge regarding the practical, how exactly AR and VR works and how those practicals can be uh, catchy for the students rather than performing physical practicals, how the students will get attracted towards those practicals using this particular technology, that is AR and VR. So that is all about monitor based AR. Now there is one more important technology, that is optical see-through HMD. So basically you will require a scene generator, optical combiners and monitors along with head trackers, graphic images, real world. So you can see this particular image. This is the entire setup which will require for optical see-through HMD. All right. Then there is another setup, that is a video see-through HMD. So again, for this, you will require a video compositor, scene generator, head tracker, video camera, monitor. And this is exactly the setup looks like, or how exactly the instrument video see-through HMD looks like, the setup or the apparatus resource which is required. All right. Now let's understand the advantages of video see-through HMD. The advantages are the flexibility in composition strategies, real and virtual view delays can be matched. Advantages of optical see-through HMD are it is simplicity, resolution, no eye offset. So this is very important, okay? Most of the time this comparison is asked, what are the advantages of video see-through HMD and optical see-through HMD. So just kindly make a note of this. Advantages of video see-through HMD are flexibility in composition strategies, real and virtual view delays can be matched. And the advantages of optical see-through HMDs are simplicity, resolution, no eye offset. Advantages of monitor displays are consumer level equipment, most practical, a lot of current research aimed and other current active area in a flip down optical display. Now there are various different types of photo detectors. You can have a photo transistor or photodiode. That is basically comes under optical domain, optical display, OTDR, optical time domain reflectometer. Now, let's understand what are the various applications, early applications which are developed using AR and VR. So, Karma in 91, Fener, optical see-through HMD. This is also one of the application. Knowledge-based assistance for maintenance. So, you can give a project for the students. Knowledge-based assistance for maintenance using AR and VR technology. It is very much, it can be implemented. Ultrasound trackers attached to assembly parts. So this is also one of the important capstone project or micro project which can be given to the students. So these are the early applications. Along with this, we have a architectural anatomy and touch guide movies. So you can watch these movies so that you will get more insight information and your doubts regarding AR and VR can be resolved or cleared. So you can definitely watch these movies, architectural anatomy and tour guide. So these movies are basically developed or implemented using AR and VR, that is augmented reality and virtual reality. There is one more application as far as mechanical background is concerned, that is ECRC. So peak, you can see how exactly the mechanical application can be implemented, that is ECRC using AR VR technology. Then certain medical applications are also developed in early 90s. Lots of work on reducing registration error, medical applications movies as well. All right. MIT medical, laser scan patient, LCD screen above patient. So these are some of the micro projects which you can give it to the students or faculties also can develop. These are actually already developed, some of the practicals, but using AR and VR, it would be more beneficial and attractive. Laser scan patient and LCD screen above patient. AR instructional reality provides a natural interface. AR games, AR quack. This is also one of the important technology or a game which was implemented. There are lots of new applications. We'll discuss some tracking systems consequently in this particular session. So this is just basically introduction or the theory part regarding augmented reality and virtual reality. Now actually we are going to see the live demonstration so that you will enjoy this particular session in detail. So now I'll stop sharing the screen and I'll play a video regarding the practicals. So just kindly give me the acknowledgement organizers, Kiran sir or any another faculty or organizers, so that it will be beneficial for me so that I'll get the acknowledgement whether screen is shared properly and video is also audible or not. So I'm sharing the screen now. I hope everybody just kindly give me the acknowledgement whether screen is being shared or not. Screen is visible. I hope everybody's screen is visible. Okay, yeah, thank you so much. Now just let me know whether it is audible also or not, because that is also very important. So I'll stop sharing the screen and I'll play it once again. Just give me a second. Okay, now do just let me know whether screen is visible or not. Screen is visible, right?
Yes, sir, it is visible.
Okay. And now do let me know whether video is audible or not. Just have a patience, it is loading. Basically, this particular practical is using measure the resistance, equivalent resistance in series and parallel using multimeter, and measure the voltage and current using voltmeter and ammeter.
Measure the resistance, voltage and current through series and parallel connected networks using multimeter.
Is it
Task
audible?
1. Resistances in series connection.
Yes, sir, it is audible.
Objectives. At the end of this exercise, you shall be able to instruments
Okay,
required.
fine. Thank you.
Regulated power supply 0 to 30 volts DC 2 ampere, voltmeter. Suitable voltage 0 to 20 volts, ammeter. Suitable current range 0 to 100 milliampere. Breadboard. Connecting wires as per requirement. Step 1. Take breadboard. Step 2. Connect potentiometer 1 and potentiometer 2 in series as per circuit diagram. Step 3. Connect digital multimeter as ammeter in series with potentiometer 1. Step 4. Connect DC regulated power supply as per the circuit diagram. Step 5. Switch on the DC supply. Step 6. Record voltage across voltmeter V1 and V2 and current across the ammeter. Step 7. Vary the potentiometer. Step 8. Again record voltage across voltmeter V1 and V2 and current across ammeter. Step 9. Now, calculate equivalent resistance. Step 10. Switch off the supply. Task 2. Resistances in parallel connection. Step 1. Take breadboard. Step 2. Connect potentiometer 1 and potentiometer 2 in parallel as per circuit diagram. Step 3. Connect digital multimeter as ammeter in series with potentiometer 1. Step 4. Connect DC regulated power supply as per the circuit diagram. Step 5. Switch on the DC supply. Step 6. Record voltage across voltmeter V1 and V2 and current across the ammeter. Step 7. Vary the potentiometer. Step 8. Again record voltage across voltmeter V1 and V2 and current across ammeter. Step 9. Now, calculate equivalent resistance. Step 10. Switch off the supply.
Okay, so this is regarding the first practical. I hope everybody practical. I hope everybody understood. Okay, fine. Now what I'll do, I'll share another screen for the second practical. Just give me a second. I'm sharing the screen now. Actually, the second practical is loading, so it takes time. Soon I'll share the screen. Just 1 second, students. I'm sharing the screen now. I have not yet shared the screen. Just give me a second. Video is loading. Give me some time. Okay, now I'll share the screen. Just give me a second. Okay, I'm sharing the screen now. Just give me the acknowledgement in the chat box, and then I'll play, and then just let me know regarding audibility also, whether it is audible or not. Screen is visible, everybody? Okay, fine. Thank you. Now I'm playing the video. Just let me know whether it is audible or not.
Activity, light dimmer using triac. Task 1. Light dimmer. Dimmer using triac. Objectives. At the end of this exercise, you shall be able to build light dimmer circuit using triac. Test the effect of resistance variation on intensity of lamp. Components required. Triac BT136, Diac DB3, lamp, L1, 60 watts, series resistance. Suitable resistance in ohm. Capacitor C1 equals 0.1 microfarad. Digital multimeter. Breadboard. Connecting wires as per requirement. DSO bandwidth 30 MHz to 200 MHz analog channels 2 to 4. Step 1. Take breadboard. Step 2. Connect resistor R1 and potentiometer R2 as per circuit diagram. Step 3. Connect diac, capacitor C1 and triac as per circuit diagram. Step 4. Connect lamp as per circuit diagram. Step 5. Plug in AC source of 220 volts as per circuit diagram. Step 6. Switch on AC source of 220 volts. Step 7. Connect digital multimeter as per circuit diagram and adjust it as voltmeter. Step 8. Measure the voltage V1 across lamp load for high intensity of lamp record in observation. Step 9. Measure the voltage V1 across triac record in observation table. Step 10. Connect digital multimeter, rotate knob and adjust it to resistance measure value. Step 11. Connect digital multimeter across potentiometer R2. Step 12. Connect DSO across G1 of triac and A1 of triac and measure the firing angle on DSO.
Okay, so this is regarding this particular practical, that is light dimmer using diac and triac. So basically these are also electronic components. So this is all about this particular session, that is AR and VR, augmented reality and virtual reality. I hope everybody understood this, the last two practicals, which was live demonstrated using AR and VR technology. Kindly give me the acknowledgement in the chat box. Really, is it interesting using AR and VR technology? Okay, fine. So this is regarding this particular session, that is AR and VR. Okay, thank you so much, all of you.